Hey guys, Steph Party here, and welcome back to episode 2 of our custom standard library. Now, last time we worked on memory allocation, which was a great thing to do because now we won't have to worry about that anymore. And I think today we should work on dynamically sized arrays or vectors. So the first thing we're going to want to do is make a new file called vector.h inside of our NSTD folder. We're going to go ahead and include it in the NSTD.h file. And we're going to open up the vector.h folder or file. And the thing we're going to want to do, namespace, NSTD, just basic stuff. Now, for a vector, it can dynamically hold any data type. Now, that may seem a little bit confusing how to do, so for now we'll just do class vector. Now, how you would do this in C++ is you would do template type name t. Now that allows this vector class to be of any type, so we can hold any data type that we want in here. Now the first thing we're going to do inside of the vector class is have some private variables. The first thing is a t pointer memory. So this will be all the memory inside of the vector. Second thing we're going to want is an unsigned long size. Now let's do length. We're going to store the length of the vector in this variable. Now we have all the private stuff down. We're going to go public, and we're going to make a basic constructor here. We're going to set memory equal to a t pointer of allocate 0 bytes because we don't want anything in there yet. We're going to set length equal to 0. So we're going to go ahead and delete all this extra memory stuff over here. We're going to make a vector, let's say, type of int v, and that actually have to be in NSTD vector, type of int v. And now this is going to run. We're going to check to make sure it doesn't crash. It does indeed run. Perfect. So this means that our constructor is working. We're also going to want a basic destructor for when the data has to be deleted. So we do delete memory, and that's it. Now we can get started in the actual meat, adding stuff to, or pushing things to this vector. So we're going to make a function called void push, and maybe a t pushed. Now t is just like standing in for whatever type we're using, so we're not going to write int pushed, we're going to write t pushed, and this will work just perfectly. Now when we push something to the array, we're adding something to the end. So that would mean we'd have to do length plus plus to add 1 to the length. Then we're going to have to reallocate the memory, obviously. So we're going to go memory equals t pointer of reallocate memory to the size of length times the size of t. Because we can't just allocate, like, let's say we were holding like a long. That would take 4 bytes to hold, except we would be placing in 4 times less bytes. So we're going to need to do times size of t for this. And then the last thing we're going to do is memory of length minus 1, which is, this is the last element of the array, or the vector, is equal to pushed. Now, this should already work for pushing something to the array. In fact, let's test this out. So we're going to go v.push 5. Obviously, we're not going to be able to access anything from here yet. But if we go v.push 5, it does run, which is a good sign. We can go ahead and make another function, which is how we're going to access things from the vector. So we're going to go const t reference at, and this is going to return the data at the index. It's going to have an unsigned long index going into it, and we're just going to go ahead and simply return memory of index, like so. Now we can even test this out now. We can actually see if everything's working. You can go stdc out, which I know still is cheating, but we're going to get to that in a later episode. stdc out v.at 0. Now, if everything's working, we should get the data 5 into the console, which we do. Perfect. We're already almost there. So this is the most basic kind of vector implementation that you would have. Now, another thing that a vector should be able to do is pop, which basically means we take the last element and delete it. So we're just going to write that real quick, void pop, which would mean length minus minus, and all we have to do is say memory equals t pointer of reallocate memory to length times size of t, because now it'll automatically forget about whatever is at the end, which we can just, now that's it. Boom, easy. Now, you may see a problem here. If the length is equal to 0, then it's going to try to make it equal to -1, and you see this unsigned up here. That would be a problem, and you can't really have an array of negative length. So we're just going to check if length is already equal to 0, then we're just going to return. So it won't do anything. Perfect. Now we have a popping operation. So we can go ahead and test if that's working by going v.push and then v.pop. And then maybe we could try to access the length. We could do unsigned long length, and this will just return length, so we can access that. Now, if this worked, then v.length should be 0. So we go ahead and take a look at this. We should see 0 here. Perfect. Now, let's see, yeah. So the next thing we're going to want to do, there's some other things you can do with an array, obviously. You might want to insert something into the array at a specific index, like 0. You'd want to set 0 to 12. Let me show you real quick. You'd have an array like 0, 5, and then 2, and then this is your array, but you want to put like a 12 right here. So to insert, you'd insert a 12 at index 0 like that, and it would just change the array to look like this. Now, this is going to be a little bit of a more complex operation, so if you weren't needing to use the insert operator, I wouldn't recommend it, but we're still going to have this for full coverage of the vector class. So the first thing is going to be tpush, and the second thing is going to be unsigned long index. And now if index is greater than length, then we are going to want to return, because if index is greater than length, then it doesn't actually exist already. So we would need to do something else, and this wouldn't work. But other than that, what we're going to do to insert at an index, let me think here. This is a bit of a complex problem. What you're going to want to do is you're going to want to say memory is equal to t pointer reallocates memory length times size of t. We're obviously also going to want to make length plus plus. Now, this just makes our thing longer. We don't really know what to do here. But if you think about it, at the index, let's see here. You have your array 0, 1, 2. What you're going to want to do is say you're inserting it right at where the 1 is right now. You see we're inserting a 9 there, and that kind of pushes the 1 from index 1 to being at index 2. So basically what we do is we just take everything after index and push it up 1. This is pretty easy. We just go unsigned long I equals index I plus plus. We're going to say memory of I plus 1 is equal to memory of I. Perfect. Now it pushes everything up, and then we can just say memory of index is equal to, we also need to say I is less than length minus 1. And then we just say memory at I is equal to length. Then we say memory at index is equal to pushed. And now we can check if this works. We can go ahead and push, maybe delete this pop real quick. Push a 5, 6, and then a 7. Push 5, 6, and then 7. And we're going to go ahead and print all those out through this simple loop. For int I equals 0, I is less than 3i plus plus, cd cout v dot at I, and then maybe a comma like so. So this will go ahead and just print our array. And then if we wanted to insert something, let's say where the 6 is, we could say v dot insert a 10 at at index 1. And I will go ahead and press go, and ooh, that's a little bit weird, isn't it? So we are going to want to do, I believe, length minus 1 for this. Or not. Hold up. It's kind of weird. Give me 1 second here to figure out what's going on. Alright guys, I'm back, and I figured out what we can do to actually fix the problem. So inside of the for loop, we're going to write unsigned long I is equal to length and then I is greater than index, and then I minus minus. And then in the body of the for loop, we're going to write memory of I is equal to memory of I plus 1, or I minus 1. And that'll push everything up. So boom, we have this insert function actually finished, and then we can insert 10 at 1. And we're also going to have to change this 3 here to a 4, so we actually print out all 4 things in the array. And you'll see we did indeed insert the 10 where the 6 was, and it goes 10, and it goes 5, 10, 6, 7. Boom, that means that works. Real quick, we're going to change this to v.length inside of this for loop so we can actually just dynamically change it however we want. Now, there's some more functions that we might want to create. Kind of like insert for push, we're going to want to do an erase function for pop, which basically what erase does is it takes in an unsigned long index, and we're just going to remove the element. We're just going to remove that element from the vector. So a bad way to do this is if, let's say we wanted to erase this 1. We delete the 1, and we move the 2. We move the 2 down to here, and then we move the 3 down to here, and then we delete the last element. That's called a ripple erase, and we're not going to be doing that. We will do that, but not right now. We have a 0, 1, 2. What we do is 0, 1, 2, 3. We actually switch the first and the last element, so it can be 0, 3, 2, 1, and then we just delete the last element. So that ends up deleting the element at the index. So let's go implement that real quick. If index is greater than or equal to length, then we're going to want to return because that means it doesn't exist. Now we're going to want to do length minus minus, and we're going to want to say memory of index is equal to memory of length plus 1. Actually, memory at length, and then we're going to want to say memory is equal to t pointer reallocates memory to length times size of t. Now this will erase the thing at the index. It'll swap it to the last index and then erase it. So what we're going to do is we're going to v.erase at 0. Let's try to erase this 5. So what's going to happen is it's going to get erased, and it's going to swap with the last element, as you see. So what it looked like is it looked like 5, 10, 6, 7. And you see the 7 should be at the end, but it's at the start, and this is actually correct. Because what it did is it swapped the 7 and the 5 like this, and then just removed the last element. And you can see this is exactly what our array looks like right now. So that erase worked perfectly fine. Another type of erase we're going to want to implement is what I was talking about earlier, a ripple erase. Ripple, we're going to call this void ripple erase, and it's going to take in the same unsigned long index. And we're going to do something a little bit different. We're also going to start with these two things because it's the same as what we're going to need. We're also going to switch it to a ripple erase so that we can try that out. Anyways, so this ripple erase is going to start at index, like so. For unsigned long I is equal to index, I is less than length, I plus plus. Actually, I is less than length plus 1, I plus plus. We're going to want to say memory at I is equal to memory of I plus 1. And then that's it, and we say memory is equal to t pointer reallocate memory to length times size of t. Boom. Now that should ripple erase, which means it just takes the 5 out, which is kind of how you would expect it to work, and you'd see that works perfectly because our array would look like 5, 10, 6, 7, and then we just take the 5 out, and our array should look like this, and that is exactly what our array looks like. So the ripple erase is now working. Now, there might be some other things that we want to add to this, but for now, I'm going to leave it at what it is. Actually, hold up, I'm not going to leave it at what it is. I'm going to add one more function, void clear. Alright, so what we're going to actually do for clear is we're going to say memory is equal to a t pointer reallocate memory for 0 bytes. Now that's going to delete all of the memory, and we're going to set length equal to 0. We go ahead and say v.clear right there. It's going to kind of clear our memory, and you'll see it prints nothing to the screen. So our clear function does indeed work. Gonna remove that because it kind of takes out all the cool stuff. So all of these functions are done. Now you might notice that there's nothing really cool going on. Also, what I'm gonna do here is I'm gonna change that to memory is equal t pointer reallocate memory 0. Just gonna kind of clean that up, but you may notice that we have to use this .at operator. This .at to get like a thing at an index, like int c equals v.at. What I'd really like to do is v of 0 or something like this, because that allows us to like treat it more like a block of memory, like a data array. Now we're gonna go ahead and try this out. We're gonna make this. Now what we're gonna use is an operator. It's gonna be a const t reference operator this, and it's gonna have an operator like array brackets or whatever, unsigned long index, which is gonna come in. And all we're going to do is we're going to return memory at index, and boom, that is our operator right there. So instead of using v.at_i, we can actually just say v of I, and we run that, and it works just fine. Perfect. So now our vector actually looks pretty to use, and it's looking pretty fully featured. I can't really think of any more functions you would need in a vector. So all we're going to do is we're going to go ahead and close that file, which is going to end this episode of building our own standard C++ library. So if you guys like this video, please leave a like and subscribe. I'll see y'all in the next episode. Bye.